So hello everyone, let's discuss electrodynamics. So starting with coordinate system, first see Cartesian coordinate system. Suppose this is x-axis, this is y-axis, and this is z-axis. Then any point represented in this coordinate system is by x, y, and z. So this is suppose r vector. Then r vector is x cap plus y cap plus z cap. So dr vector is dx x cap plus dy y cap plus dz z cap. And if I want to write dA vector, let's suppose in xy plane, then it is dx into dy into dy into z cap. Okay, so similarly if I want to write dA vector in yz plane, then it is dy into dz into x cap. Now if I want to write dv in electrodynamics, we write it as d tau. D tau is dx into dy into dz. Okay, similarly let's see spherical coordinate system. So in a spherical coordinate system we have, suppose this is z axis, this is x axis, and this is y axis. So in this coordinate system we represent with r, theta and phi, where theta is the angle with the z axis. So this is theta, this is r, and if we take projection of point P on xy plane, then this projection P prime, what it makes with the angle x with x axis, that is phi. Okay, so here we write dl vector equals to dr r cap plus r d theta cap plus r sin theta d phi cap. Okay, so now similarly like in Cartesian coordinate we have written dA and d tau. Similarly in spherical coordinate it is, if I want to write dA in, let's suppose r theta, okay, in r theta plane, then it is dr into r d theta into phi cap. Okay, similarly if I want to write dA in, let's suppose theta and phi plane, then it is r d theta into r sin theta d phi into r cap. Okay, now if I want to write d tau in this, so d tau is the product of all the three differentials, so it is dr into r d theta into r sin theta d phi. Okay, now let's next move to the cylindrical coordinate system. So in cylindrical coordinate system we have, like this is z axis, this is x axis, this is y axis. So in this coordinate system, if any point P is there, it is represented in a rho, phi and z. So this rho is similar to the r, which represent this distance, and phi is the projection angle, the angle which the projection make with x-axis, and z coordinate is this, so this is z. So in this coordinate system we write dl equals to d rho cap plus rho dt phi cap plus dz z cap. Okay, so if I want to write dA vector in rho and phi cap, then it is d rho into rho d phi. So a product is this, and here z cap. If I want to write d tau here, that is d rho into rho d phi into dz. So what we have to remember in all the three cases is this dr. So Cartesian coordinate is very similar, very simple. In spherical coordinate this is dl, and in cylindrical coordinate this is dl. Okay, so now then let's move to the next section, that is about vector operators. So first let's see what is gradient of a scalar. So we will see first, let's see in Cartesian coordinate how to calculate gradient. in Cartesian coordinate, let's suppose in Cartesian coordinate it is very simple. Del s equals to del s by del x cap plus del s by del y cap plus del s by del z cap. Okay, in spherical coordinate system, we will calculate del s like del s by del r cap plus 1 upon r del s by del theta cap plus del s 1 by r sin theta del s by del phi cap. Okay, so now let's move to the cylindrical coordinate system. In cylindrical coordinate, we calculate del s equals to del s by del rho cap plus 1 upon rho del s by del phi cap plus del s by del z cap. So now let's move to the second section, that is divergence of a vector. So in Cartesian coordinate, we calculate divergence. Divergence is nothing but del dot v. Okay, so in Cartesian coordinate, we calculate del dot v equals to del s by del x plus del vx by del x plus del vy by del y plus del vz by del z. If v is like v equals to vx x cap plus vy y cap plus vz z cap, then del dot v is like this. Similarly, in spherical coordinate system, we calculate del dot v like del dot v equals to 1 upon r square del over del r square vr plus 1 upon r sin theta del upon del theta v theta into sin theta plus 1 upon r sin theta del v phi upon del phi. Now let's move to the cylindrical coordinate system. Del dot v equals to 1 upon rho del over del rho plus 1 upon rho del over del phi v phi plus del vz by del z. Okay, now let's move to the curl of a vector. Curl of a vector is defined as del cross v. So in Cartesian coordinate, we calculate it like that we do dx cap, y cap and z cap, del by del x, del by del y, del by del z. Here we write vx, vy and vz. Okay, in spherical coordinate, what we do? In spherical coordinate system, we do r cap, theta cap into phi cap, and here we multiply r and r sin theta, del by del r, del by del theta and del by del phi. That we do ar vr into r into v theta, r sin theta into v phi. Okay, in cylindrical coordinate system, it is here one more term I have left, that is 1 by r square sin theta. Okay, so now in cylindrical coordinate system, 1 over rho cap, rho phi cap, k cap, del over del rho, del over del phi, del over del z. Here we have v rho, this is v rho, this is rho into v phi, and this is vz. Okay, so try to remember all these formulas, especially for the gradient and divergence. If you don't able to remember curl formula, then it is not too much necessary. Okay, you can remember in Cartesian coordinate only, but try to remember divergence and gradient in all three coordinates. So now let's move on to the next section. Let's discuss some of the general laws related to the operators. Okay, So the first law is if I calculate from A to B gradient a line integral of a gradient, okay, then it only depends on the endpoints, okay, it does not depend on the path taken. Second theorem is also called as divergence theorem, or Gauss theorem, also called as Green's theorem, okay. Try to remember all the three names. Green's theorem, try to remember all the three terms, okay. So here we have del dot V d tau equals to V dot dA, okay. So this is the divergence theorem. It says that volume integral of the divergence equals to surface integral. Third theorem is so called as Stokes theorem. Stokes theorem is we have del cross V dA equals to V dot dl. So it says that surface integral of a curl is equals to line integral. So remember all the three laws. Now let's move on to the Gauss law. So Gauss law is, the statement of the Gauss law is del dot E equals to rho upon epsilon naught. Now let's see, if I apply this divergence theorem to this Gauss law, then what happens? Let's see. Del dot E d tau equals to E dot dA, okay, surface integral of E dot dA. What is this? The rho over epsilon naught d tau equals to E dot dA, surface integral. So what is this? Rho d tau. This is Q enclosed. So here we get integral form of Gauss law, E dot dA equals to rho Q enclosed upon epsilon naught. So we have two formats of Gauss law. That means this one is integral form and this one is differential form, okay. So now let's move on to the next section. So now let's see what is boundary conditions. So in this chapter we have lots of questions based on Laplace equations. So in all the problems, usually in all the problems, we have these 4 boundary conditions which I am going to tell you now, okay. So if there is any surface, then we have, let's suppose this one is E, where it's medium 1 and this is medium 2, then we have E1 perpendicular minus E2 perpendicular equals to sigma over epsilon naught, okay. And the second one is boundary condition is E1 parallel minus E2 parallel equals to 0. Third boundary condition is V should be continuous on this interface, okay. And the fourth boundary condition is V should be finite, okay. V should be finite. Now let's move on to the next section. So we have now Poisson's and Laplace equation. There are 2 types of equations. This, what we have is del dot E equals to rho over epsilon naught from Gauss law, and we know that E is equals to minus gradient of V, okay. So if I put E from this here to here, we get del dot minus del V equals to rho over epsilon naught. From here we get del square V equals to minus rho over epsilon naught. So this is Poisson's equation. If rho equals to 0, this equation gets converted into Laplace equation, which is del square V equals to 0. So now this video is very long now, so let's discuss solution to the Laplace equation, this equation del square V equals to 0, in the next part of this video, okay. So stay tuned.